Hi students. So this is going to be your, let's see, this is the third video lecture that you're going to have for Monday. And this one is going to go ahead and wrap up the PyClient. We're going to do a couple of things here. If you remember, let me go first to the app that I've got running. So in Chrome, you've got a PyClient that was like kind of halfway there, at least on the client side. There's server stuff that we still haven't touched, but we've got a nav bar with the picture. We've got a logout component over here that doesn't actually do anything just yet. We've got an authorization component that lets us toggle between login and sign up. If you remember the information for email, password, first and last names, we can dig into the React Inspector tool and see that all of that information is stored inside of the state of that component. So that auth component has email, first name, last name, login, password. Okay, we can toggle to the other. When we do, we built out the method that toggling between the two will clear the information there. Login has all those same state properties of first name and last name specifically. Even though they go untouched, that's fine. We don't have to use state properties unless we want to. So that's kind of where we had left things off. So the goal now is we won't technically finish the client because the client and the server have to talk back and forth. Remember, the client is your visual tool. It's the tool that the user interacts with to both input and to get information. But the client is not capable of persisting data. That's what the server is for. So that includes making sure that we have a valid user that we're trying to log in with and the Pi information. That doesn't, unless we hard code values into the front end, which is a pretty wonky thing to do, then we don't have the Pi set up like we want yet either. Or I should say we won't have by the end of this video. So let's go ahead and move forward with the PyClient. What we will do, we're going to set it up so that we're going to kind of mock getting a valid user back that will let us get past this authorization component. And we're going to have mock Pi information as well that will show up in a table after this point. So let me go over to Visual Studio Code. That's my notes. That's good. I want to make sure I know where I'm supposed to be at. Okay, cool. And I am in, so again, my folder structure probably looks a little different than yours. I'm in a folder called JavaScript Jan 2019. I'm inside of JavaScript library. Hopefully you guys are too. I have just kind of silly 0 and 1 folders, nothing in them, and a 5-React fundamentals that we'd put together last Monday. So I'm going to open up the PyClient and check out what I have inside. I've got app.js. I've got components for auth and navbar so far. Auth has a subcomponent for logout. Auth has a single component that allows us to toggle like we talked about. And I want to add to my component tree. So I want to add pies. So I'm going to do that inside the components folder here. And I'm going to make 2 files there, pies.css and pies.js. Okay, now pies.js is going to be, it's going to technically be the table that shows the Pi information on a Pi by Pi basis, but it's good design to not make a component that handles too big a job at once. So the Pi is actually going to sort of outsource the work that it is to do to show the entire table to a Pi component that I'm going to make inside the Pi folder. So I've got Pi inside of pies, and Pi is going to be responsible for showing just a single row in the table. Okay, so we've added 2 new folders and 4 new files. Let me make sure that matches up with the notes. Yep, okay. And I'm going to do a couple of things here that I think will feel familiar. In pies, we're going to first do an import of React from React. Standard fare there. We're going to import the pies.css. And we're going to import the Pi component too. And I'm going to call that pi from /pi pi. Okay, easy peasy. All right, now the next piece is less familiar. I'm going to do a copy paste here. Oh, that's interesting I did it that way. Okay, let me go ahead and grab this. I'm going to do a copy paste, and I'll let you guys pause the video to grab the data and input that yourselves. So we're going to say that this is a class component, I believe. Let me get my head on straight. Yep, class pies. Okay, so class pies extends, and I don't have component imported, so I'll do react.component. And I'm not going to set up a constructor just yet, but I will. What I just copied and pasted here, rating, it's going to complain about that. Let's do 3 and 5. So our rating system for these pies is out of 5. Okay, so what I just imported, let me highlight this, and then I'll give you guys a second to pause the screen if you want. Test data is an array, as you can see, because it's got the square brackets starting in line 7. It's got 3 objects inside. The first object, well, notice all 3 objects have the exact same properties. Name of pie, base of pie, crust, time to bake, servings, and ratings, rating, right? All the information in a table has to meet the requirements of a same data format, right? So they've all got name, base, crust, etc., because they're all going to, the information is going to line up in columns for us. Okay, the first object is going to sit at the top of the table, and it's basically just our column headings. Hence, we don't have particularly interesting strings up there. The next 2 are going to be sample pies for us: cherry, fruit filling, pastry crust, 30 minutes to bake. Servings, sure, 97. We're making a massive cherry pie. And then we've got pecan here as well. Base of pie, sugary goodness, crust, graham cracker, etc., etc. Okay, so this information, all of this test data, this is just mock dummy data. Later in the building out of our app, certainly by Friday, maybe by Wednesday, I can't remember the timing just offhand, we're going to grab this data from the server rather than playing with hard-coded values here. This is not what we want the app to do long term, but it will be a good testing tool, and this is really smart app design as well. As you build an app, you don't want to necessarily, you should have an end goal in mind, but you can't necessarily just get to your end goal by coding your way through a brick wall to get there. We don't have a server, so rather than just trying to simultaneously build out our front end and build out the server, go ahead and mock things. This is called stubbing your code out. I have stubbed information. This is not the long-term solution, but at least it lets me know if this component will work. I can test with this, okay? All right, so what's next? So I've got that dummy data, and then I think I'm gonna do myself the favor of copying and pasting the next piece here. You guys can, again, pause the video to grab what you need, but this is gonna be a lot easier than me trying to look between screens as I'm on a single monitor here. Okay, so notice first, this is a good visual clue. Pies is kind of darkened here because we've not exported it. It's basically going unused inside this file. But the interesting stuff is happening inside of render. Okay, so render we know is the painting lifecycle method for a class component. Pies is a class component. Pie rows comes from a dot map. Well, so just seeing a variable in this dot map, I know that I'm grabbing an array and returning an array. Dot map's job is to do exactly that. Its input is an array, its output is always array. Well, test data, that's just the variable array we established at the top of the class. So we're mapping, or we're iterating, we're cycling through these 3 pie objects. The first one, again, is basically just column names. And what are we doing? With each pie object, we're returning the pie component that we have yet to build out with a key of pie.name of pie. So I've not talked about keys much before. React expects keys when you have repeated, what's the best way to generalize? When you have repeated lists, if you have repeated components, if you have repeated, frequently arrays of components. You'll see it a lot here. Pie rows is going to be an array of these. We have 3 pies, so we'll have 3 pie component calls as well. But React needs to be given a key to know. Remember, React is trying to update components at an appropriate time. It wants to know if it should or if it should not update a component. Without a key, React may inappropriately update all 3 Pi components, thus using extra CPU cycles to do unnecessary work. When you pass a key to React, you're then saying, hey, this is basically a name, React, that you can use to keep track of this component, and you can update it when you know that it's appropriate, not just whenever. So this helps to save, it's really an efficiency tool. It's internal to React, but that's an efficiency tool. So that's not a prop, but Pi is a prop. This is information, that's the DNA that gets passed down to the Pi component. The Pi prop is literally just the Pi object. Notice we're passing down Pi, not pi.name of Pi, pi.base of Pi. Pi is the entire object. I'm highlighting one of the 3 that will be passed down there. Okay, so Pi rows is 3 Pi components. Each one gets a Pi object. Then inside the JSX, this is really cool. I thought this was super neat the first time I saw it, and it's still cool. You throw in the curly braces inside of JSX. Inside is a JavaScript variable. Okay, that's no problem there. We define that up in line 35. But that JavaScript variable is an array, remember, of 3 Pi components. React can make sense of those 3 Pi components, and I don't have to worry about writing that out here. It knows that that's an array of components, and it will render each of them on its own. Pretty cool. Okay. I think you'll see this more in just a second. If I try to explain it further, I think I'll just add to the confusion rather than clarify things. So the last thing I need to do, I need to export default Pis. I think that's all I want. Let me make sure, double check with my notes. Yeah. Okay. So I think I hit the biggies there. So if we try to run this app, which I'm trying to do right now anyway, notice nothing's happening, and that goes back to the fact that we have now made a Pis component. We've made a tool, but that tool has not been used, right? The tool is sitting around in our app folder structure, but it's not called in app.js, and it's not called in any other component either. So it's not going to make or break the app just yet. We still have to call it. All right, so let's jump over to pi.js, and Pi is going to have, I'm going to do another copy paste here because it's a small file, and I will try to remember better this time to pause. There you go. You can pause the video and go ahead and type the code lines out yourself. So Pi has the job of just showing, well, I see a TR, so Pi is returning a single table row with 6 table data cells. Those are the individual blocks in a row for a table, and each one shows a different piece of information. Remember, the prop that got passed down from Pis had a name of Pi. So to access the Pi prop, it always starts with this format. Inside a functional component, it's just props dot. Inside a class component, it would be this dot props, which is just a little nuanced difference there. But props.pi, props grabs hold of all the props passed down to this component. Props.pi says, I want the Pi prop specifically. And what do I want for that? Well, I want the name of the Pi. How do I know that the Pi prop has a name of Pi? Well, that's as simple as this Pi, remember, is one of these 3 things. Each of those 3 objects has these 6 specific keys. So I'm literally just matching the names here with the names of the keys inside the object defined in our test data array. Okay, that's not too bad. So this returns a single row in our table. And let me see where I want to take this next. Okay, let's add some CSS, can do. We're going to add this to pis.css. So we're going to basically, we're going to style the entire table that we're building out here. So notice I'm grabbing, I forget the terms, but I'm grabbing any element in my Pis component that is either a table or a table data. And I want a border that's 1 pixel. I want that to be a solid border, and I want it to be black. I want border collapse to be set to collapse. If you don't set this, it's kind of interesting. For some reason, I think it goes back to like old school CSS, but tables by default have like just a little bit of cushion between them, and it just kind of looks funky. You want all the rows to like touch each other and not just have little white gaps between them. You should take this out on your own and see what it does. I'm going to skip that. We also define some rules for the table, and you have seen these before. We say we want the table to be 50% down from the top, 50% over from the left, to have an absolute position, so it's not like relative to its containing element. It's absolutely wherever we set it. And we want to translate that minus 50%, minus 50%. So this allows, these two are going to set the top left corner of the table in the center of the screen. This will shift it so that we're moving the table to truly be in the center of the screen. Let's take a look. Oh, we still haven't called our pies component yet. So what do I want to do next? I think let's go ahead and call this. I think that's smart. Let me go to app.js. Yeah. Okay, we're going to call that pies component, and we're going to be a little bit silly here. We're going to stick it right underneath auth. So this is going to look funky, but whatever. We can go with funky. We're learning. Import pies from /components. Pies, and remember you don't need your .js extension. Let's call that. Oh, I've got a break elsewhere too. I'll take a look at that in just a second. So pies gets a call here. Test data is not defined in pies, so I must have made a typo. Oh, I did make a typo, yeah. So test data is a variable on the pies class. Just like when you want to access a function inside of render, you want to access a variable inside of render or inside a function within your class, you got to throw in this dot. Now I get a redundant alt attribute. Screen reader's already announced image. Oh, I'm not worried about that. And so, okay, so I knew it would do this. This is a little weird, but we're seeing all three of the big components that we've built out on our screen at the same time. We've still got the auth component there, but we can see more or less what the pies component will do for us. We've got a table, and we see our data filled into that table, right? And so how that data, remember, came about because it was, oh, I keep selecting the wrong one. Here we go. We've got our test data inside of pies. That gets passed down to pie. So if I look in Chrome, I should see within app, within pies, I see 3 pie components. And I like how if I click on one, it hovers just that row. Each one has a different key because each one had a different pie name. I see the JSX children of that pie component. That's cool. And so, yeah, this looks wonky, but you can start to see that the different views, as they're called, the different things that the user are going to see are within our app, okay? We don't have a great way to get past the authorization screen just yet, but you can see the data that the user will interact with after the authorization screen. That's cool. Okay, so where to next? Let me come back here. I'm not quite sure why I took it this way, but that's okay. We're going to finish this up in the next part anyway. We're going to update app.js. So oh, okay, cool. I like where this is going. I had forgotten. Okay, so in app.js, we've imported pies. We're going to actually take out this pies call. We're going to clean this up a little bit. And inside of app.js, we're going to finally add a constructor. Why? Well, not because we want to use props. That would be a good reason to use a constructor. We're going to add state. Okay, why are we adding state now? Well, we're finally to a point where we've got, as you guys saw back on this screen just a second ago, we've got different views we want to navigate between. Well, what's the what's the conditional that we're going to use to look at the authorization component versus the pies component? That conditional is what we call, let me make sure I called it the same here. Yep, that's what we call a session token. What's a session token? A session token will be the server's verification that we are a logged in, pre-established user in our database, right? So we're gonna mock this a little bit too until we've got a server and a database to go with it. So we're gonna say the session token is undefined. What I want to do, I'm gonna call this a view conductor. If there's a better name out there for it, great. I'm gonna copy and paste this, and I'm gonna explain what it's doing. So, and I do not like that I made it. I love me some arrow functions. There we go. Okay, so I made this an arrow function. So the view conductor, it doesn't take anything as input, but it uses, notice I'm returning and I see a question mark, I see a colon. We're using a ternary here. Okay, so what is view conductor doing? It's saying, look at the session token inside of state. If that is not undefined, return pies. Well, that makes sense. I want to show the pies component we just built out if I don't have an undefined session token. That is to say, if I have a session token returned from the server, that session token is going to be like literally a 100 character, like all jumbled up string that's an encrypted, it's encrypted user data. If I have a user data, this session token shouldn't be undefined, and I want to show the user the pies component. If this is still undefined, your else is return the auth component. Okay? So how do we use this? This is also pretty sleek. I'm going to take out auth now because I no longer want to say auth is showing all the time. I only want to show auth when I don't have a session token, or more explicitly when session token is undefined. So I call my view conductor here. I do this. Oop. Oh, it corrected it for me. Sweet. This dot view conductor. And here I will use parentheses. I'm calling the function all the time. That function gets used anytime I'm inside the render because view conductor is responsible for helping us paint to the screen either pies or auth. Okay, so what do we see? Well, we see an auth component. If I look inside of app, I see that, oh, I'm not crazy about it, what it shows here. It shows an empty state object, and that's because an undefined session token, React is saying, hey, you probably don't care about that, so your state's empty, okay? Well, let's change this up a little bit. Instead of saying that the state session token is undefined, let me go back here. If I make it just a random garbled string, now we're past the auth screen because our session token is no longer undefined. App, it's showing me I have a session token property inside my state, which is that like random string thing that I just hard-coded in, and we're past auth now. So here too, we're mocking getting past the authorization screen, but you can see the functionality of our app. If I take that back to undefined again, we should see the auth component. And we do. And I see an empty state object because React thinks we won't care about an undefined session token. Okay, this is pretty sleek. This is a really cool paradigm that you'll want to use in React from time to time. I see almost everybody use it in their Blue Badge project, but it's just really awesome regardless. This idea that you don't have to determine in your JSX exactly what you want to show. You can outsource the job of determining what needs to be painted to the screen to a function, and that function can do the decision making for you. In this case, it was with the ternary. You certainly don't have to always do that with the ternary. You can make, if you've got lots of different components you would want to show under different conditions, you could make a switch statement with cases for all of those components. You can do lots of if-elses, even though those are not necessarily the most elegant thing to use, but lots of tools are in your toolbox here. Okay, cool. So that takes us through what we were going to do Wednesday, and then we had just a little bit Thursday that we're going to do here. Let me make sure, actually, why? I think I was thinking that there was more to it than this. That is really, really minor. Oh, but yeah, I'm actually going to skip the Thursday stuff until we've got our server good to go. We're going to come back to our Pi client and Pi server and connect them once our server is doing something for us. So instead, we're going to pause on the Pi client here. I'm going to go ahead in VSC. I'll close out that app. I'm going to navigate up in the folder structure. So I'm back to 5-React Fundamentals. And I'm going to make a new app here. This one's going to be small, but I think something that a lot of people don't really have a good grip on. And quite frankly, some of this stuff is just like, you don't use it a lot, but it's still important to be aware of, even if you don't use it a lot. And that's the lifecycle process. We've talked a little bit about before how the lifecycle is only a feature in class components. Functional components don't have those. Functional components don't have a constructor, don't have a render, don't have component did and will unmount, don't have a component will update. We call it a lifecycle because React does not fire off the constructor and the render simultaneously. It has a cycle that it's continuously going through. Some of the lifecycle methods, as they're called, only occur once in that lifecycle. Others occur anytime you're going through that circular process. Okay, so how are we going to get started with this? Well, let's go ahead and make a lifecycle demo app. This is also kind of interesting. If you refresh a page that looks like it's working when you've closed out the app, you can see in the terminal I'm not running anything. You should get site can't be reached. That's usually a hint that you're not running anything. A lot of people see that. Okay, so I want to be here. React Fundamentals. So create React app lifecycle demo. Now let this run. Another cool trick in VSC that I like to use, if I've got all 5 of these little tabs open at the same time, I can do Command KW and it closes them out for me without closing out of VSC, which is great because those tabs were for the other app. Don't care to be looking at that. So I'm going to look at my notes here real quick. So we're going to take a look at render, the constructor, component did mount, hopefully the API we're going to pull from won't go down on us. Should component update, and component will unmount. Okay, great. So let's check still not installed. Yeah, so while this is working, hopefully you guys are enjoying React. I love it. It's so cool. I think that it's got so many like neat abstractions that when you guys were playing with vanilla JavaScript and vanilla HTML and Gold Badge, it felt like, okay, yeah, I can start to make a web page, but there's a lot of like just stuff you have to do by hand that's annoying, and it took you away from the more interesting coding. And hopefully you're starting to get to some stuff in React that's just like cool to you. All right, so let me go to my lifecycle demo folder, npm start this, double check that it's working okay. We're not going to build anything big here, but you don't have to be building big to build something for learning. And I'm not a crazy fan of it doing this. There we go. Okay, so single app there, great. So our app is up and running. I'm going to open up that folder structure here, take a look at app.js, and I think I want to gut that. Yeah, so let's change app.js render to just be the following. Oop, I just copied that. Did not mean to do that. Let me copy again here. Okay, so I'm going to paste this over. There we go. Okay, I don't care about the CSS and the logo. Not what I'm interested in right now. So render is your first lifecycle method. We're familiar with what it does. It paints to the screen. You have to return to do that. And the way we're going to flow this lifecycle demo is by doing a console log in each new, well, most of the time, we're going to do a console log in each new lifecycle method we want to inspect. So notice I'm not returning anything interesting. We're not going to see anything on screen, but this is what we want to pay attention to. And we're going to follow this structure. The component name, and we're inside of render. Okay. So if I go to my console, I can see, sure enough, I'm console logging. There's no conditional logic here for the console log to fire. So app.js recall gets called in index.js. Index says, hey, take this component, render it inside of the root element sitting inside index.html, right? So take our component, render it inside div that has an ID of root, okay? So when that happens, because this is a class component, React is looking for our lifecycle methods. It only sees one right now. Sees the render and it fires it. And notice, we've talked about this before, I'm not seeing a second inside render or a third. I see a single time inside the console that we're inside of render. So again, React is smart enough to only to repaint, which is an expensive operation for your computer. It's only going to repaint something to the screen if the information for that component changes. In particular, if the props or the state change. There are exceptions to that, but in general, if the props or the state of a component change, then the component will update. We only see it once because the component has not changed internally. Okay. All right, so what do we want to do next? Let's go ahead and make a constructor. And this constructor, what we want to do is compare when the constructor gets fired versus when the render gets fired. So here too, we're saying constructor props and super props. App.js is the great grandfather of all of our components. So these are not needed because we have no props that we're going to pull in from any higher level component. We've got a console log here to see when the constructor is firing compared to when the render is firing. We set up a state object with the name of one of our instructors, and we set a property of Swappy people. Swappy is the Star Wars API. It's really easy and friendly to access, and the people that we're going to grab from that at a later point. That's initially empty. Okay, so let's go back here, and you may have expected this. We see the constructor happened before the render. Well, that makes sense. Logically, if the constructor is building out our component, we want to fire the constructor first so that if render needs to be able to access information in the state has to exist. So the constructor happens first, builds out our state, allows us to grab props if we need to, then the render happens. Okay? So we're at 2 lifecycle methods so far. Okay. Now, okay, this one is a little bit cooler. We're going to add component did mount. So couldn't tell you why it's called, and I'm going to change this to an arrow. Oh, nope. I can't do that on component did mount. So I couldn't tell you why it's called component did mount versus component did render, because component did mount triggers immediately after the render method. Okay. It's called, when the component is painted to the screen, it's called mounting to the DOM. And remember, the DOM is your document object model. So we should see constructor, render, component did mount. But let's take a look inside of component did mount and see what we're doing here. We're console logging again, so we get verification that there is an order to the lifecycle methods being fired. We are fetching from an API. Don't worry about this URL. Just know that this URL is going to give us Star Wars characters back. We take that response, we turn it into a JSON object, a JavaScript object notation. Without that, it's just a string. Res is a kind of a string that gets passed across the web. This allows us to actually interact with it as JavaScript. Then we know returns a promise. If JSONifying the response was successful, we go to the next dot. We go to the next dot then. If that failed, if the Swappy fetch failed, then we go to the dot catch. We catch whatever error gets passed from a rejected promise, and we console log that error. Okay. However, on success, we take the JavaScript people. We're going to set the state so that swappy people is the result of that JavaScript object. And that's just going to allow us to grab the people inside our JavaScript object. Dot notation says this JSON is an object. We're going to grab a property inside. Set state right here has an interesting mechanic where after you set the state by declaring an object like we did, highlighted, you can then throw in, after a comma, you can throw a callback function. So why are we doing this? Well, you wouldn't do this all the time. This is not necessarily like a super useful tool, but it is if you're not sure what set state is doing. It's really smart to throw in this arrow callback function to just console log our state object and see that in fact it has changed. Okay, so I'm doing a lot of talking. Let me go back to the code. Okay, I'm going to do a hard refresh here. So we start inside the constructor. That's expected. Then we go inside the render. Okay, that matches what we said earlier. Constructor, paint something to the screen. Then we see inside component did mount. Okay, also expected. Then we see inside render again. Interesting. That's interesting. Well, why would this happen? Well, that goes back to what we said like 3 or 4 or 5 minutes ago, that the component gets repainted to the screen when its internal information changes. We changed the app component internal information with a set state right here. We took swappy people, and that was initialized originally to an empty object, but then we set it to be the results. So we're changing the information in the state brain. Well, React says, oh, you're changing the information? You need to re-render. Something about this component has changed, hence that second render call. And then we just see, it's kind of interesting here too. So after we set the state, React goes to the re-render, and the render actually fires before the callback function. That's kind of interesting. I think intuitively I would expect if we take our JavaScript Star Wars people and we set the state so that they're stored inside our state object, I would expect the console log to show up before the render, basically just because this is shorter, but it doesn't. React is super efficient about recognizing a change inside that component did mount and repainting to the screen. And then we see our console log after that. And we see that, sure, Star Wars people, I see Luke, C-3PO, etc., that got updated from our fetch and component did mount. Okay, so we've got 3 lifecycle methods so far: constructor, component did mount, and our render. 2 to go. All right. Thinking I may slash just a little bit of this. Okay, nope, this is good. This is good. All right, what we're going to do next, we're going to set an, oh, I keep doing that. We're going to set an interval inside our class. And wait, where did I have intended to put that? Oh, inside our component did mount. Oh, okay, great. Let's go ahead and put it right there. Okay. So now, what's happening here? So set interval is it's a useful tool. However, it's not a tool that comes from React, and therefore React is not managing it. Set interval comes from what's called the window object. The window object, so JavaScript apps are actually one huge object that contains lots of things inside. Set interval is a function on our window object. And long story short, again, it's just not managed by React. So what does it do? Well, set interval fires off a function. In this case, it's just a simple takes no input, but it console logs this output is from our interval. And it does that once every specified number of milliseconds. So that's 10,000 milliseconds, or every 10 seconds, show this output is from our interval. And we see that. So it's been 50, now 60 seconds so far since that interval has started to fire. Well, that interval just sits there. Because React doesn't manage it, it's taking up both CPU and, more importantly, memory space. This is a potential memory leak unless we get rid of this somehow. So how do we do that? Because set interval doesn't get managed by React, we need to explicitly manage it. Think about how, in contrast, think about how when we define state here inside of app, we never have to explicitly delete state. We just trust React to manage that for us. But again, we've got to manage the set interval. So we're going to use another lifecycle method, component will unmount, which just means the opposite of component did mount in some sense. It's leaving the screen, it's leaving the DOM, and I'm doing this a little bit out of order. That's okay. What we want to do inside of that is to clear the interval. Clear interval, and VSC is so nice, it gives us a little helper suggestion right here. Oh, I should have, okay. So clear interval, I don't think I coded this out in the notes quite right. So one way you'll frequently see this set up, I'm trying to think on the fly as to how I can show this real well. So set interval is usually going to be set equal to some sort of variable. So I'm going to do this dot interval equals set interval. Okay. Now the first thing I want to do to make sure that that shows up all right, I'm going to go back to my app, and I'm going to wait 10 seconds or so and see whether or not we start to see a console log. Great. Okay, that's what we want. This output is from our interval. So this the interval variable inside our class is the interval that we set. And it's doing what we saw before every 10 seconds. Clear interval, the way you have it here, it makes it look like it just clears all intervals. It doesn't. It needs you to refer to a specific one. Okay, so now we set an interval here and we clear it down here. This is, so the trick, the trick is that we're going to see all of this but the clear interval. And even if I throw in a console log here, if I say app.js inside component will unmount, this won't actually show up in the console for us. I mean, technically it will, but it's going to disappear so fast. And I don't have a way to make app.js leave the DOM. So this is going to go unshown in our console log for now. But that's okay. So I want to explain what we're trying to do here. So think about the life cycle so far. So we know constructor fires once. We know the render fires at least once. Component did mount fires only a single time. Notice how after that second render, we didn't go back to component did mount. That's also a single fire lifecycle method, just like the constructor is. Component will unmount is also a single fire. But you're not going to see this one because the only component firing in our entire app is app right now. So this will go unused unless we leave the page. And if we do, let's go to Facebook, right? Well, I certainly didn't see it in the console. Why? Because to the best of my knowledge, the console is going to clear when you're going to a new app. If I were sitting inside this same app that I had built out before and just went to a different component within it, then we could see component will unmount firing. I'm getting into the weeds a little bit. Okay, last thing I want to do for you guys. I don't think we've done that before. Oh, yeah, this is a good one. Okay, let me go ahead and show this. So last lifecycle method, should component update. So should component update has a simple job. We talked earlier about how the props in the state change inside a component trigger a component's refiring, right? Well, should component update is a filter for that process. What it's going to do, think about how we went constructor, render, component did mount, then back to render, okay? So this time, component did mount is going to guide us to should component update before the render. We either return true or false. Now you can do this conditionally. You may want to say something like, and I'm just going to do pseudocode here. If there is no meaningful change in state, don't update component, which would lead to us returning false, right? And then we could do else return true, okay? So I'm not actually using code, but you can kind of see the logic here. So we return true or false based upon whatever conditions we set. For now, I'm just going to return true, so I'm not checking anything. I'm just saying, sure, if there's a props or a state change, do go ahead and repaint to the screen. So let's see this. So come back here, and sure enough, we go constructor, render, we grab our Star Wars data, then we go to should component update. Should component update return true for us? So we give the OK to render to repaint to the screen. And there you go. Okay, so that's our short and sweet little lifecycle method demo. Those are 5 lifecycle methods that are really big, really important. Constructor for initialization, component did mount for fetches in particular, render for anything painting to the screen related, component will unmount for, happens a lot if you've got things that React doesn't handle that you need to handle on your own. You need to be aware of not having memory leaks. And then should component update, I have used occasionally, but think about why it might exist. If we know that updating the component to the DOM is an expensive CPU operation, then should component update will save us some CPU cycles and control when things actually change on screen. That's why it might exist. Hey, thanks for hanging with me. I know this was a long video, but we had a lot of ground that we wanted to cover. I've really enjoyed working with you guys. I want you to reach out to Autumn, Zach, and I if you've had any questions. We're going to keep these videos going for the foreseeable future, and if they don't work well, we'll figure out something else instead. Cheers, guys.